Hey everybody, it's Mrs. Dr. B. We are going to be doing some stoichiometry today, mass to moles, moles to mass, mass to or moles to liters, and liters to moles. So this is our options today. I'm going to try to get each one of these problems. These are the same problems we're working in class. So this video is mostly for review. If you need to see it again, or for those of you who missed class. All right, so let's go. Let's get this done. All right. So problem number one, the first problem we're going to work in class today is this one. It says when 1.5 moles of KClO3 decomposes, that makes this my known. How many moles of oxygen are produced? That is my unknown. Okay? So we know that KClO3 is my known, and we know that O2 is my unknown. We're just going to go ahead and leave those there. The next thing we have to do, however, is we have to look and see which portions of this map we need. Nothing about representative particles. I do not see anything where it asks us about molecules or anything there. The only thing that we're asking about, or we know about, on the KClO side is moles, which means guess what? I don't need any of this. It gets covered up because I'm not using any of it in the problem. All right, now let's look on the O2 side. What are we looking for? We are looking for mass. We are not looking for representative particles. I'm going to cover this up. I kind of messed it up when I fixed something just a second ago, but we're going to kind of cover it up, pretend like it's not there. And we also do not need to know anything about liters. Okay? We're not doing anything at all about the volumes. Let me cover this up as well. So there's our problem. All right? Our problem is set out here. We know we are starting with 1.5 moles of KClO3. We know we are looking for the mass of O2. All right, with that in mind, our problem is very simple. We start here, and we know that we have 1.50 moles of KClO3. All right. We know that we put at the beginning of each one of our problems the question mark. How many grams of O2? We have now identified my known and my unknown. We have talked about this in class several times. We're going to continue talking about it. And what we know is that when we have these two things, we know the next step is to put a multiplication in fraction bar. We also know that whatever is in front of the multiplication bar has to be the denominator behind the fraction bar. All right, so what we are doing when we move from moles of the unknown to moles of the known to moles of the unknown is we are multiplying by the molar ratio. Now, I have heard some people say this, and I think it's a very valid point. And I'm just going to do this, guys. The molar ratio is the heart of every one of these problems. You can't do it without it. Just understand, not a single one of our reaction stoichiometry problems can be done without that. Make sure you know moles of the unknown over moles of the known. So we need to have moles of O2. And where are we going to find the numbers? We're going to find them right up here. 3 moles of O2. And how many moles of KClO3 is shown right here? 2. And I just wrote a 2 up there on the top one. 3. Okay? Now, the reason why we do it this way is because we get to cancel. All right, moles of KClO3 get to cancel. Now we have moles of O2. We are right there. We have successfully gone from this side to this side. My job is, I got O2, that's fine, but I have moles, I want grams. That means I've got to do something else. Got to do another fraction bar. I said whatever's before the fraction bar on the top has to be on the bottom of the fraction bar, the denominator on the back side. And this is 1 mole. Why? Because it says molar mass of the unknown. And the molar mass of oxygen is 32.00 grams. Our moles of oxygen cancel. And now we just do our math. And guys, what we're going to do is we're going to take 1.5. We'll multiply it by 3, divide it by 2, and multiply it by 32. And what we end up getting as our answer is 72.0 grams of O2. We can verify that we have the right setup because guess what? I forgot to write O2 here. But I'm looking at grams of O2 and I have grams of O2 over here as well. All right, so that's the first problem. Okay, guys, so we are back with problem number 2. Problem number 2, we're going to use red again for the known. It tells us that we have 80 grams of KCl. That means we know that KCl is our known. What are we looking for? We are looking for number of moles of KClO3. That means that is our unknown. That allows us to find our molar ratios very easy. One more time, we've got a full stoichiometry roadmap. We don't have anything to do with particles here. When we are looking at the known side, we do have mass, which means we can't cover this. But we don't know anything about liters. It doesn't have liters in the problem, so let's cancel volume, or let's cover up volume. All right, now let's look at the unknown. What does it ask for? It asks for moles. It means we don't have to go past moles to get to mass. Let's cover it up. We aren't going from moles to molecules because it doesn't say anything about particles or molecules, and it doesn't have anything about liters again. So one more time, what we have done very quickly, and you guys are welcome to do something like this at home, is we have identified our problem just by looking at the words of the problem. Okay? So, as always, we start our question mark, our problem here, with, in fact, this, and we're going to say question mark moles of KClO3. That's what we're looking for. What do we know? We know there are 80.0 grams of KCl. That's just our setup. And we know that our setup includes having a multiplication fraction bar. And whatever is in front of the multiplication sign has to be in the denominator, in the units, behind it. So that would be grams of KCl. So we are moving from mass, and it says right here to multiply by the molar mass, which is grams. And the molar mass of KCl is 74.55 grams. And the definition of molar mass is this many grams KCl per 1 mole of KCl. That's the definition of molar mass. All right, guys, let's cancel our units. And we have moved successfully from mass of KCl to moles of KCl. We started here, and we're now to there. All right? We want moles. We have moles, but it's the wrong compound, so we have to move across the dotted line. And when we move across the dotted line, our job is to put whatever is on top of the numerator in front of the multiplication sign beneath it. So that is moles of KCl. And we have to put, because we are now multiplying by the molar ratio, moles of the unknown. So I need to just write moles, and the unknown is KClO3. So how do we find those numbers? Again, we find the numbers by simply looking here. Here's how many moles of KClO3. That would be a 2. How many moles of KCl are there in the equation? There's a 2. Which makes this math problem an easy problem, guys. Let's cancel our units. And notice we will have at the end moles of KClO3, which is what we were looking for. So we know we have it set up right. So in this problem, we are going to just simply take 80 and we are going to divide it by 74.55. Sorry, you can't read that anymore. And if you feel so inclined, you can multiply by the numerator and then divide by the denominator. That's kind of a waste of your time. But guys, what we end up with is 1.0, let me start that over, 1.07 moles of KClO3. And that would be your answer. Okay? So again, what you're doing every single time is you're identifying what's in the known and the unknown and covering up what you don't need. We'll come back with problem number 3. Okay, so we are back with problem number 2 and this 3, and this one's a little bit different. Let's read and see what we have. It says we know that we have 0.75 moles of KCl. That means we know what we are doing is we're starting right there. I'm not even going to worry so much about the rest of this stuff anymore, guys. It says we know this. So let me just put my known right there. I could go ahead and to make it easier for those of you guys who need this, I can cover this up. But I've gone ahead and put my name right where I need it. All right. Now, what are we looking for? We are looking for liters of oxygen at STP. That means what I need to do is I need to put this down here. I need to put the O2 down at the bottom because that's what I'm looking for. I'm not looking for representative particles and I'm not looking for mass. So one more time, I can use the roadmap to identify where I'm starting. I have to do step number 1, go across the dotted line, and we know we use the heart of every problem, which again is going to be the molar ratio, to get from moles of the known to moles of the unknown. We need to use then for moles of the unknown, we need to multiply by the standard molar volume number. Standard molar volume. Standard molar volume is 22.4 liters of gas per 1 mole. This is a number we've talked about before. It's a number you're going to be using right now. Okay? So guys, this makes this even easier. We don't even need to use molar mass. We know right from the beginning our problem, all right? And our problem reads as this. We know that we have 0.75 moles of KCl. That's what it tells us right there. We know we are looking for how many liters of O2. So there's our beginning setup. In order to go across the dotted line, it tells us we have to multiply by the molar ratio. For those of you who are still needing it, remember whatever is over here on the left of the multiplication sign has to go on the denominator of the fraction bar behind it. And guess what? That's what it even tells us to do. It says moles of the known. Moles of the known. And then what are we going to put on the top of it? It says moles of unknown. All I'm doing is putting in the units right now, guys. Now, what are the numbers? 3 moles of O2. 2 moles of KCl. We cancel moles of KCl. And guess what? We've now gotten to the oxygen, but we don't have the correct units. We want liters, and right now we're looking at moles. What does that mean? We keep going. We're here, and it says right there, we're going to come down, multiplication, fraction bar, and it gives this one to you. Look what it says. It says to put 22.4 liters over moles of O2. And how many moles is it? It says 1. And by doing this, we cancel out moles of O2, and we end up with 22.4 liters, and it's specifically of O2, which is what we were looking for. All right, so let's do the math. Basic fraction math says I'm going to multiply 0.75 times the numerator divided by the denominator, and then I'm going to move to the next fraction, times the numerator. And since the denominator is 1, I took 0.75 times 3 divided by 2 times 22.4, and the number that I get is 2.52 liters of O2 as my answer. Okay? All right, we got one more problem to work. Okay, guys, so here we are on our very last problem. Let's go ahead and do this. Again, if you don't have the roadmap in front of you when you're working your problems, I'm going to suggest you get it out there because it's so much easier. What's it asking for? Ooh, I'm going to put that in red. I don't want to do that. I asked the question first. How many moles of KClO3? That means, guess what? I'm going to put it right there. Moles of KClO3. That means I'm going to cover up everything behind moles because I don't need it. That's where I'm going to stop. I'm going to find my socks. I'm not going to look any further. Okay, so that's what I'm looking for. What did I start with? Well, I started with 29.63 liters of oxygen. That means I'm starting down in the lower left-hand side. What does that mean? It means I don't need mass, don't need molar mass for either one of these problems. So there we are. There's my setup. My setup says I'm going to take the volume of O2 that I know and I'm going to multiply it by standard molar volume. That's going to be the first thing I'm going to do. Then I've got another step where I'm going to multiply the moles of the known once I get it there by the heart of every problem, the molar ratio. And when I do this, guys, I will end up where I'm supposed to be. All right, let's just do this. So what do we know? We know we have 29.63 liters of oxygen. What are we looking for? We are looking for moles, question mark, moles of KClO3. And what are we going to do? We are going to multiply by the standard molar volume. But the number that has to be at the bottom because I've got liters of oxygen, so I have to have liters of oxygen at the denominator, and we know the number is 22.4. That is the definition of standard molar volume. So that liters of oxygen will cancel, and this is 1 mole of oxygen. What we're doing, guys, we get to cancel. Liters of oxygen cancel. And we are now at moles of oxygen, which means I get to move my little to there. We've made it from step 1. All right, now what's step 2? We've got moles. That's good, but we have the wrong compound. So that means we now have to move across the dotted line. And what does it tell us to do? It tells us to start with, at the bottom, moles of the known. Why? Because we want to cancel it. What are we going to? We're going to moles of the unknown, KClO3. And look what it tells us to do. Moles of the unknown over moles of the known. Now all we have to do is get the numbers. All right? There's 2 moles of KClO3 in the reaction. There are 3 moles of oxygen. Look, moles of oxygen cancel. And we end up with moles of KClO3, which is what we were looking for. So what's the math in this problem? The math in this problem is 29.63 divided by the denominator of 22.4. You could multiply by the numerator, but guys, we know 1 isn't going to matter. Okay, 29.63 divided by 22.4 times the numerator divided by the denominator, and I get 442.47. That's a lot of fleeking. 442.47 moles of KClO3. Right? That's how much it says we're going to do. I hope I did not. 29.63 divided by 22.4 times 2 divided by 3. That's right, because we have, oh, you know what? That is wrong. I multiplied. I thought that sounded kind of weird. Divided by 22.4. I apologize. Times 2 divided by 3. Much better. 0.88 moles of KClO3. I apologize. Hopefully I won't make the same mistake in class tomorrow. All right? Yeah, make sure this divided by that. That's what I said, and then I pushed the multiplication sign on my calculator. So, all right, guys, that's it. See you tomorrow.